Hello guys, welcome back to another video. Okay, so, well, how many prime numbers are there? Now, do we have an exact estimate? Is it finite? Is it infinite? Now, if it is finite, then what is the largest prime number? And guys might have heard the famous problem. Are the number of twin primes finite or infinite? Why does that question even come up? Now, if we know that the number of prime numbers are finite, then we know the number of primes will be finite. That question can only come up if the number of primes are infinite. Now, do we know that the prime numbers are infinite? Well, let's prove that in today's video. Okay, so for this video, I'm going to assume that you guys know what a prime number is. But just to recap, a prime number is any natural number which cannot be divided by any number other than 1 or the number itself. For example, 5 is a prime number. It cannot be divided by any number like 2, 3 or 4. Now, any number can only be divided by numbers which are smaller than it. Or basically, any number which is larger, any number x cannot be divided by any number which is larger than x in any case. 7 is a prime number. 16 is not a prime number because it can be divided by 2, 4 or 8. 2 is the smallest prime number and it is the only even prime number. Okay, now let's look at Euclid's proof of why there should be an infinite number of prime numbers. So first he starts by an assumption that there are finite number of prime numbers. So let's say that there are n prime numbers. Okay, now let's say, since there are n prime numbers, there must be a maximum prime number and a minimum prime number. So let's order them. Let's say P1 is the smallest prime number and it goes all the way up to Pn, which is the largest prime number. Now this is important that Pn is the largest prime number. Now if Pn is the largest prime number, that means that any number larger than Pn cannot be a prime number. So this is the assumption we have, that Pn is the largest prime number. Now let us construct a new natural number, x, which is P1, P2, all the way up to Pn, the product of all the prime numbers, plus 1. Now x cannot be prime. Now if x is not prime, then it has to be divisible by at least one prime number. And all the prime numbers which exist in this world are P1 to Pn. So let's say x is divisible by Pi, which is one of these prime numbers. So that would mean that x by Pi belongs to natural numbers, which means that P1 all the way up to Pi minus 1, Pi plus 1, all the way up to Pn plus 1 by Pi is a natural number. Now since this is already a natural number, we have 1 by Pi is a natural number. Now since Pi is greater than or equal to 2, so this entire thing is less than or equal to 0.5 and all natural numbers are greater than or equal to 1. This cannot be true, which means that x is prime, which means that Pn is not the largest prime number, which means that there cannot be a largest prime number, which means that there are infinite number of prime numbers, which is really, really cool. And this work was done, like I said, Euclid gave this theorem. Euclid is probably one of the most important mathematicians, though I think according to me, the greatest mathematician is Euler, and my favorite is Newton, but Euclid is just up there. He has done so much cool stuff that is amazing. Anyways, I hope you like this video. I hope you comment on this video for stuff you like or recommendations for other videos. I hope you share this videos with anybody you know who might appreciate content like this, and I hope you subscribe to this channel for more related content. And thank you for watching this video.